Hi. After watching this presentation, you should be able to explain the test protocol that is normally used with boundary scan test boards and the actual test procedures that are used to implement the various stages of that protocol. So let's start with the test protocol. I'm considering the protocol as the sequence of stages, and the procedures, as we will see later, are the sequence of actions. But this is merely a matter of choosing what words you like better. We first have to start by checking that the boundary scan chain interconnections are working properly, and this stage goes frequently under the name of integrity test. Then we might start by checking for the presence of short faults among boundary scan pins, because their potential for damaging the board is somewhat higher due to the currents that will be flowing among the shorted outputs. From there, we can move on to check for the presence of open faults. Then we may start with the test of non-boundary scan clusters, and we may conclude by checking the proper operation of those integrated circuits that support built-in self-test. Notice that we need to synchronize the boundary scan chains with the external test equipment that will handle the input and output connectors. We may ask if this sequence needs to be as shown here every time, and also how will a non-boundary scan cluster be tested, but I leave that up to you in order to keep the presentation short. Let's now consider the basic test procedures. The main test actions follow this sequence, which starts by setting up the required operating mode for each boundary scan device. You will normally place the devices in external test because that's the operating mode that will let you drive the test vectors through the boundary scan outputs. But you can use the sample preload mode if any given device is used only for capturing the test responses. Then we must shift in the bit stream that sets up the required fault detection conditions. And after updating the outputs, we will capture the test responses and start to shift them out, while a new test vector will at the same time be shifted in. And we need to repeat this process for all test vectors. So except for the first bit stream, whenever you shift in a new test vector, you will be shifting out the responses to the previous test vector. And because you may not know what is in the boundary scan cells before shifting in that first bit stream, you may wish to start with all devices in sample preload, so that when you move to the external test mode, you know what values will be driven out of the boundary scan outputs. You may now consider this example, which I will not explain here, since I want you to think and try to answer by yourself. How many of these faults will be detected if you set all the outputs of IC3 to 0? Assume that only one fault is present at each time, and notice that you will need to know how the test vector driven at the outputs of IC3 propagates through IC1 and IC2. And that's all. Thanks for your attention.